This is the Earth, and this is the axis of rotation, and it's about 23 degrees off of the vertical, the plane of the elliptic. The sun's rays come in perpendicular to the vertical, and so this is the line that the Earth rotates on, and that would be the North Pole. And this is the equator. There's a line of latitude here, 23, I think it's 23 degrees north of the equator. And then there's another line the same way, 23 degrees south of the equator. But North Carolina is above 23 degrees. It's above that line. My point is, between these two lines, that 46 degrees, sometime during the year, the sun can be directly over your head at the zenith angle, directly over your head. But in North Carolina, we're too far north. We're too far from the equator for the sun to ever be over our heads. In North Carolina, the sun is never directly overhead at any time. So my point is, my shadow is always facing north. If I was standing in my yard, if the sun was this way, my shadow would be the other way, and my shadow would be pointing north at noontime, because the sun rises in the southeast, sets in the southwest, and it's to my south, due south, at noontime. And I'm talking about local noontime, not daylight savings time. And so if the sun is out and you can see your shadow, or if you can see any shadow of anything, those shadows at noontime are facing due north, because the sun never gets directly overhead where you're standing in North Carolina. And that is a way of approximating where due north is, astronomic north, lines of longitude. Another thing you can do is wait till you can see the North Star. I think it's called Polaris. That North Star does wobble a little bit around your line of rotation of the Earth, but not much. For the most part, like backyard homemade surveying, land surveying, the North Star is stationary at the North Pole. So my point is, if you were standing here looking at the North Pole, the North Star, then you could set, your helper could set a stake, set a stake here, set a stake there in line with the North Star, and you would have two stakes lined up on due north. Another thing you can do is if your magnetic compass is pointing to magnetic north, and you know that today's magnetic north is 11 degrees off of true north, then what you could do is set a stake here, set a stake here, and then turn that 11-degree angle and set a stake there, and then you would have an approximate due north angle to your North Star or to your North Pole. And after you know where true north is, grid north would be about 1 degree east of true north. That's where I live, in Onslow County. In other areas, you would have to find out what that angle is. If you were in the western part of North Carolina, then grid north would be to the west of true north. To give you an example, let's say North Carolina is like this. This is the mountains, and this is the ocean. The 0 point is south and west of North Carolina. So Onslow County is over here, and we are 2.3 million feet from the 0 point. So our eastern coordinates would be 2.3 million feet from there. And our northern would be a few 100,000 feet from our reference point, our 0 point. Of course, actually, the 0 point would be south of any point, the lowest point of North Carolina. So you'd be measuring up from here. And there's a line of longitude going up through the middle of North Carolina where grid north and true north are the same. And these lines of longitude converge as they go to the North Pole. But the grid north lines are all parallel to each other. And the advantage of that is when you're working with grid north, you can assume that North Carolina is completely flat. But the geodetic surveyors that work with the whole planet Earth, they work with more difficult mathematics because they're working with numbers where the Earth is not flat; it's a globe. And that's why in Onslow County, true north is longitude, and then grid north is a little bit east of that, just 1 or 2 degrees east of true north.